Let's do a quick example using dimensional analysis. Here we have output power W dot, shaft power, as a function of torque and angular velocity omega. So step one is to just write out the variables in that form. Step two is to list the primary dimensions of all these variables, and in terms of primary dimensions, mass, length, time, etc. The primary dimensions of W dot power are m L squared over T cubed. The primary dimensions of torque are m L squared over T squared. And the primary dimensions of omega is 1 over time, since omega is radians per second and radians is a dimensionless unit. Now let's pick, step 3 is to pick the reduction j. What we usually do is try, first of all, j equal to the number of primary dimensions in the problem, which is here 3. We have m, l, and t. And step 1, I forgot to write, we count the number of variables, so we have n equal 3. Step 3, we predict that we will have n minus j equal 3 minus 3 equals 0 pi's, or non-dimensional parameters. Now clearly that's not possible. We can't have 0 pi's. So in cases like that, we start over and instead we try j equal 1 less than what we had, 2, and now we expect n minus j equal 3 minus 2 equal 1 pi. And that's probably going to work for us. Step 4 is to pick the repeating variables. So we pick j equal 2 repeating variables. Remembering our rules, we have to pick 2 out of the 3 that are available, but we can't pick the dependent one, W dot, on the right side, so we really have only one choice. We have to pick the 2 remaining parameters. We pick t and omega. And then step 5 is to create the pi's. And so how we do that is we pick one of the other variables. Let's pick the dependent variable first, W dot, and then multiply that by each of the repeating variables raised to some unknown exponent. So pi 1 is W dot t to the a, omega to the b, and what we're going to do is force that pi to be dimensionless. So the dimensions of pi 1 are dimensionless, so all the exponents have to be 0, no dimensions, and then we write out the dimensions of each of these parameters from step 2. So we have m L squared over T cubed for W dot. For T, torque, we have m L squared over T squared, and that's raised to the exponent a. And then for omega, the dimensions of omega are 1 over T, and that's raised to some exponent b. Now we're going to force this pi to be dimensionless, and what that means is, let's write out for example, that's for mass. M to the 0 on the left is m to the 1, m to the a, and there's no b. So from this we can write 0 equal 1 plus a, equating exponents, and therefore a equal minus 1. Let's do the same thing very quickly with L. For L, we have 0 on the left, and then we have an L squared. Up here we have an L to the 2a, and we have no other L's. So 0 equal 2 plus 2a, which also gives us a equal minus 1. Fortunately, these match. If they didn't, we'd be in deep trouble. Probably look for algebra mistakes first, or perhaps the problem is not well posed and we can't solve it. Finally, for time, t to the 0, there's a t to the minus 3. Here, there's a t to the minus 2a, since it's raised to exponent a, and a t to the minus b on the right. And when you work through the algebra for that, we plug in A, do a little bit of algebra, you get B equal -1. And so our pi 1 equal W dot over T omega. Finally, step 6, the last step, is to express the pi's as functions of each other. Generally we write pi 1 equal function, the dependent pi is a function of all the other independent pi's. Here, pi 1 is W dot over T omega, and it's a function of nothing. Since there's no other pi's, there's only one pi in this problem. Therefore, the only way that can be true is if pi 1 is a constant. And so our final answer is that W dot is a constant times omega t. That's the answer we get from dimensional analysis. Now it turns out we cannot find this constant by dimensional analysis, but if we do an experiment or if we do some physics, we find that the constant is actually equal to 1. There's no way we can know that from dimensional analysis alone, but notice that we get the answer to within that unknown constant, and that shows the power of dimensional analysis.